Okay, today we are going to look at vectors. Now, vectors have two very important characteristics. They have a magnitude and a direction. A magnitude is just a measure of, you can think of earthquakes, of how strong this particular vector is. It's a measurement, it's a quantity. So something like 7 or 7.2 or 144, all of those could be magnitudes. They are quantities. They are measures of how much is in that vector. The direction is also something that is needed to have a vector. You must have both of these. So this could be, you could say it's northwest. You could say that the vector is 47 degrees. You can give you got to give some sort of direction for where it is going in addition to the quantity. Without both of these, then you don't have a vector. So speed by itself is not a vector, okay? So I could be traveling 88 miles per hour, but where? What direction? Now, if you think back to physics for a moment, velocity is a vector. You could have 88 miles per hour south. It gives you a direction, the south, and the magnitude of how much, the quantity of the speed. You can apply this for many different things too. In terms of moving something, you could say like if you're traveling, I'm going 10 miles. Well, 10 miles by itself is not a vector, but if I'm going 10 miles east, now you have a vector because you've got the magnitude and the direction. Let's take a look at what some of these look like. So I can have a vector here that I can call vector, I've got 2 points, A, B. I can call this V, okay? Lowercase v, we can use W. We like to use lowercase letters for our vectors. I've got an initial point here, which is where the vector starts. And I've got a terminal point up here, which is where the vector finishes. It is not the same thing to go from B to A. Not the same. But to go from A to B, that would be a vector. Also, to go from B to A is a vector, but it's not the same vector because the direction is totally the opposite right there. We call, again, the starting point the initial point, where the vector finishes the terminal point. So let's say I've got two vectors here, and I want to combine them. I want to do vector v to something, and then I want to do vector w. So I can take v and take w and do what's called head to tail addition. So I can take the tail right here from w and connect that to v in order to get v plus w. And if I do that, then I'll get that guy looking something like that. There's w. And your new vector would look something like this. This would be v plus w. It's combining them. It's basically going up this path and going to the right together. They combine to take you to the same terminal point. And you see this, if you think of the streets of Chicago, you see this all the time. You can take two streets, like you can take Chicago Avenue, and then you can take Damon to go west and then north, or you can take Milwaukee Avenue, which will just cut you down a more direct route. You still can end up in the same place. And we're not really concerned about shorter routes right now. We're just concerned about the final end result. Where do you end up? So again, here is our combined vector. A little bit clearer here with everything else taken out of the way. This is v plus w. Okay. So let's say you've got v minus v. Okay. Let's say you don't want to add, you want to subtract. Well, in this case, you would go up v, and then you would have, this is really negative v. So you'd go in the exact opposite direction, and you would end up exactly where you began. So v minus v, when you're talking about vectors, would give you 0. Now you could also have something else, something like v minus w, if we go back to the example that we used earlier. So there's v, and let's say w is a vector like this. If it's minus, it's actually just going to be in the exact opposite direction that it was. It's going to have the same magnitude, okay? So the magnitude is the same for negative w, but the direction is going to be the opposite. So your new vector, if you had v minus w, would end you up right there. Okay? You will often see vectors represented as within these pointed brackets. So v equals 5 comma 2. Think of this just as you would think, but very similar to how you would think of coordinates on the xy plane. This is, first one is your horizontal, and then the second here is your vertical. So if I'm going to start and apply this vector v to my starting point here at 3 comma 4, I've got to go 5 horizontal, so that's 1, 2, 3, 4, 5. So I know I'm going to end up somewhere about right here. And then I've also got to go 2 positive vertical. So I start out at 4, so I'm 1, 2, 3, 4. So I would go 1, 2. So I would see the intersection of these two, which would be right there. So there is my vector v applied to that. And that's it. My new point would be right there, which I counted out, would actually give me 8 comma 6. One other thing you can do with vectors is you can multiply them through a thing called scalar multiplication. So what this does, it does not affect direction. It only affects the magnitude. And you can see here that if I've got v and I've got 2v, basically I'm doubling the length from v to 2v. I'm almost basically stacking 2 v's on top of each other. You could think of it as that this could be a v, and then I could have another v right there. Same thing. Same thing. And we're taking a scalar is really a real number. Okay, it has no direction. It's just a quantity. So you can use this as well to manipulate vectors. All right, we will be looking more at these. Please bring in your questions and have a great day.